Alright, so we're going to work through problem 4.1 from chapter 4 of Taylor's Classical Mechanics. This is a problem proving the product rule for the dot product of two vectors. And we have that d over dt vector A dot vector B is equal to the derivative of vector A with respect to time dotted with vector B plus vector A dotted with the derivative of vector B with respect to time. So I'm going to start by creating our vectors here. And create B the same way. All right, so we'll find each part of this on its own, and that's how we'll end up proving what exactly this works out to be, and show that this is equivalent on both sides of this expression. So we can find dA over dt, which operates on each component of the vector. So we're going to have dxa over dt, dya over dt, dza over dt, and we'll do exactly the same thing here for vector B. From this point, we can go ahead and find A dot B. Can find A dot B, which is going to be XA, XB plus YA, YB plus ZA, ZB. And we can go ahead and take the derivative of that, and that is going to be dxa using our regular product rule, not a vector product rule yet. That's what we're trying to prove. Using our regular product rule, we can show that this is equal to that. So now we have a few things that we found, and we are able to put them all together. So these are some of the things that we found that are going to be useful to us. And we also need to know our vectors here. So once again, it's stated up here that we're going to have that derivative that we just found is equal to the derivative of the dot product is going to be equal to the derivative of A with respect to time dotted with the B vector. So let's first do that. Let's do dA over dt dot B, and each of these, so that's going to be dxa over dt xb plus dx, dya over dt yb plus dza over dt zb. And we'll get a similar result here for derivative of the b dotted with our a, yb going to actually be YA and then ZA. You'll notice that if we take these results here, add them together, as we're supposed to be adding dA over dt dot B, dB over dt dot A, we get the same terms as we do following from up here. You're going to get that term right there. This term's going to come next, then get that. And we have shown that these are exactly the same expression.